I'm excited to introduce you to the newest member of the Kendall Hunt family, C++ Data Structures by James Helfrich. For those of you familiar with the first edition, you will find many of your old favorites with a few exciting new improvements. C++ Data Structures is designed to facilitate a variety of different approaches to teaching data structures. If your class focuses on using data structures to solve programming problems, then C++ Data Structures offers a great deal of support. By using the standard template library as the interface, you can use the text to teach your students how to use the STL and look at the many interesting problems that can be solved with it. If your class focuses on data representation aspect of data structures, the text and accompanying teaching materials provide many powerful illustrations to help your students visualize how the data structures work. Implementation details are also provided so they can create their own working data structures. And finally, if your class focuses on matching the code to standard interfaces, C++ Data Structures will provide an invaluable reference to provide interface, algorithms, and unit tests. Providing the teaching materials will guide your students through the process of creating their own data structures, exactly matching the functionality of the STL. So let's take a look at the text. So first of all, we'll take a look at the table of contents, and you'll see that all the standard template library data structures are represented, including things like integers and floats and binary trees and linked lists. Well, let's take a look at one of these. We're going to jump into the vector. Now, first of all, we always present each chapter with the definition of the standard template library, including the standard interfaces as they're provided, and graphical illustrations how it works. Then we also have the implementation section, which shows you how to implement it, including details, including pseudocode, and sometimes C++ to show you how these things work. Then we also have application, a couple different problems we can solve, classic problems such as the Fibonacci and infix to postfix notation and things like that. We have some examples showing step-by-step how given lines of code map to manipulation of data structures. After this, we have some exercises. And these exercises are provided on the app, the accompanying app, which will turn us into quizzes. And also we have solutions in the slides. And finally, some problems, which are going to be more robust. Each chapter follows the same basic pattern. We have definitions, implementations, application, examples, exercises, and problems. So regardless of how you structure your course, we have plenty of teaching material to facilitate your specific needs and to help your students be successful in what they need to do. In each case, we have illustrations and pseudocode, each carefully designed to have maximal visual impact to help the students understand how this works. The examples are going through with example code and to show what the resulting data structures do, and of course exercises, and the students can fill in their answers into the textbook if that's how you choose to teach the class. And finally, each of the problems will have sample solutions there as well. There is also one slide deck for every chapter of the textbook. This slide deck represents all the key points that are found in the chapter. Each slide deck has a definitions, implementation, application, example section, and you can click on these links at the top of each slide deck to jump around, which means that no single slide is more than 2 clicks away, and this facilitates you answering questions or to teach the class in any way you choose. Let's take for an example the definition section. I'm going to jump straight to the summary, and then I'm going to hyperlink into the access section, and this will show you how to access things in this case, the vector. Let's hop the insert, and then we have some animation to show how each line of code modifies the linked list one at a time. And we have similar animations for all the different aspects, so you can demonstrate how these things work and answer the students' questions. In the implementation section, we have a discussion on algorithmic efficiency, just like we do in the textbook. And then we also show how different aspects of the code works. How to insert an element to a linked list, for an example. You can click through and show how each line of code corresponds to a manipulation in the underlying linked list. These types of illustrations are presented throughout the textbook. in the examples bit. Here we have some code, and we'll show how this line of code corresponds to a given aspect of the linked list, and so the students can follow along as you explain how things work. The exercises part, you can turn these into reading quizzes, or you can have them do it in class or do it for points and have students ask a question and then click on it, and you can have them see how they respond. And also have the students work through this problem, and then you can click through to see how the different lines of code map to the resulting linked list in this case. And similar illustrations and demonstrations exist for all the different content provided in the textbook. Another powerful teaching tool provided in each chapter are unit tests. If you have the students implement, for an example, in this case, a binary search tree, then we have about 50 different unit tests to exercise various parts of it. And each unit test has some ASCII art at the beginning to show the student the before, the exercise phase, and then the after. And the after part includes a SPI, and the SPI is going to measure how many times it's been copied, allocated, compared, or assigned. And then we show ASCII art to show what it looks like afterwards. And so you can provide the students with these unit tests and ask them to write the code to match it. And in each case, they can see what the test is supposed to exercise, and they can get a little bit closer. And this unit test will tally up what percentage of the test have passed. So you can take their code, put into your project and run it, and then you can say, oh look, 84% of the unit test pass. I can enter an 84 directly into the gradebook. This makes for objective and repeatable grading almost instantaneous. I also provide my students with stub data structures that compile and then pass the unit test with 0%, and then they can work on their data structures a little bit at a time to get closer and closer to the end here. And that makes it really easy to grade, and it also gamifies it a little bit so the students can find it can be rewarding, and they can, if they do 10 minutes of work, they can increase their score by 5% or something. So this is C++ Data Structure, 2nd edition. I hope you can see that this is a complete solution, easily adaptable to a wide variety of course outcomes as well as teaching styles.